30 minutes, it's all about volleyball, a sport that is played competitively at highest level in both sexes by females and males. And volleyball has to offer a large number of very diverse and dynamic situations where players have to adapt to the specific needs and to perform in constantly changing environments. And this is especially demanding when it comes to complex movements. And a good example in volleyball for a complex movement is the most iconic, the spike jump. The spike jump is very important because it's the most frequently used attack, and it is even decisive for the outcome of matches. Why is this? Because of ball velocity. A spike jump allows for great ball velocity, and the higher the ball velocity, the less time available for the opponent to react in time properly. So ball velocity is an important criteria defining the quality of a spike jump. The second one is jump height, because the higher you jump, the larger the effective field size. These two are performance criteria recognized in the practical training and in scientific literature. How does the spike jump work? I want to focus on the two last steps because they are independent on the player's individual preference. The first is the long pen alternate step, where we apply arm swing and upper body movement to generate momentum that facilitates the later upwards acceleration. We plant the dominant leg first. Dominant means the side where it's the striking arm. Then comes a delayed and asymmetric planting of the non-dominant foot. And we convert horizontal velocity into vertical one, followed by a push-off phase where we accelerate the center of mass upwards. And after takeoff, we transition into flight phase, where pelvis, trunk, shoulder, and elbow movement is involved to spike the ball partially. These characteristics are important for a spike jump, and they in fact correlate with jump height. Jump height is important not only in males but also in females, but we see differences in performance between sexes. And the most simple but incomplete answer for these differences in performance is existing differences in biology. We know very well about a bunch of differences in terms of body mass, several muscular features, and even anatomy. And we also know that these affect human movement and performance. So there is the conclusion that differences in performance can be reasoned only or mainly by differences in, for example, anthropometry and strength. But this conclusion is fortunately outdated because what is about other factors that influence performance, such as technique and coordination? When you take a look into very basic movements, walking, running, throwing, and also for most interesting jumping, then we see differences in movement characteristics. In these very basic movements, when talking about jumping, I'm talking about counter movement jumps, squat jumps, drop jumps. And then these authors interestingly found sports-specific differences. They were able, based in counter movement jumps, to identify the type of sports an athlete trains just on the basis of the force time profile in the ground reaction forces. So this indicates and tells us to consider sport-specific jumping analysis. We have one example in soccer, where we know there are sex-specific patterns in a sport-specific, in this case soccer-specific jump. But how about in volleyball? Most studies were conducted in males only. So what do we actually know about sex differences in volleyball-specific jumping? And what do we know about performance determinants in females? I want to give a short overview. There's this study providing a wide range of variables, quite helpful, but the limitation is that the insights are limited due to its nature of being a conference paper on 2 pages. Another problem is the small sample size leading to statistical issues. The second study by Subtitles they indicated sex differences appearing in the arm swing and approach, but they did not analyze the actual arm swing and the actual approach. What they did is comparing the jump height with and without arm swing, with and without approach. And then the last one investigated a female sample only and compared it with findings in male samples. In these other studies, also other methodology was applied. The same study also addressed the issue of performance determinants in females. They only focused on the center of mass, besides having the problem of small sample size. The same problem of focusing on one variable was seen in this study, focusing only on the arm swing. The problem hereby is, even if we see some correlations here, we have no comparison to other variables, and we have no idea if this variable is preferably to be addressed in a specific training compared to other variables. And then last, Ikeda et al. Did a comprehensive study about, for us, unfortunately, mainly strength and power related variables. The only variable they investigated telling us something about the technique was the center of mass, but they found differences here between the sexes. If we knew about differences between females and males, and if we knew the determinants in females, then we could develop a training that specifically addresses and improves technique and coordination. And this could have some benefits, like having less physiological stress than other training interventions. How could we do it? The one approach is a traditional one, where we present an ideal model to the athlete, who tries to replicate it and repeat it over and over again, getting corrections from the coach. And the goal is to reduce the discrepancy between the current performance and the desired ideal model. On the other hand, we have alternative approaches, and one example is the differential training, where I want to give you some more information, rather about the principles, but then the methodology. And the fundamental principle in differential training is the existence of movement variability. We can never repeat a movement twice or more times in the identical fashion. We know this for a long time already, and recently we also know that this movement variability is not only unavoidable, but it's also beneficial. Beneficial to adapt to different situations, and beneficial to exploit the specific dynamics in the different situations. So the idea is to integrate the movement variability into the training practice by adding variations, how to perform the technique. For example, this can be variations in terms of joint angles, how to grip a ball stick in this case. If you imagine on each of these axes one variable, that could be the depth of the counter movement. What we observe in nature very often is an inverted U-shaped correlation between a characteristic and the performance, meaning that in case of the depth of the counter movement, we will go lower and lower. First, this is beneficial for increasing the jump height, but then comes some point of turn where we still go further low, and it's getting detrimental for the performance. And somewhere in between the negative extremes is a positive effect and an optimal. So the idea is to provide a range of variations, to provide a scope within the athlete can find solutions how to perform a technique, and step by step decreasing the discrepancy in the variations, allowing for individual adaptation towards an individual optimum. So the aims of the overall project were first to detect sex differences in the movement characteristics of the spike jump. Second, to identify these factors that determine the performance in females. And third, to implement and assess a specific technique training for females. Background of the first study is we are aware of sex differences in basic movement, but not so much in spike jump. But it is a fact that the transfer is done from male findings and best practices to females. Obviously, if we don't know about sex differences, such transfer is not valid and leads to severe consequences in practice and in science. So the aim of this study was the detection of sex differences. This was done with the help of two teams, one female, one male, each consisting of 15 players, and as you can see, the script is of both teams quite comparable. They were invited into the lab, doing a general and a specific warm-up, and then familiarizing themselves with several test trials where they needed to hit two force plates in the ground separately with each foot. And during these test trials, we also adjusted the board position, which was suspended from the ceiling. When they felt familiar, they performed 10 various bike jumps with maximal jump height and ball velocity. These trials were collected with Wacom cameras and empty force plates, and also EMG data, although limb muscles were collected. The data were put into virtual 3D, where they were handled with a 3D full body model. They were filtered according to the recommendation from the literature and normalized. To give some examples for normalizations, time variables have been normalized to the duration of the trials, forces to body mass, and EMG to peak activation. The most important variables and their calculations are jump height, calculated by the vertical velocity of the center of mass at takeoff. The counter movement, defined as the difference between the minimal vertical position of the center of mass during counter movement minus the vertical position during standing still, divided by, this is in this case the normalization, the same position in the still stance. And then approach speed, defined as the horizontal velocity of the center of mass at landing. Then there have been some joint angles in shoulder, hip, knees, and ankles, defined as the sagittal change of the angle between these segments adjacent to the corresponding joint. And in this presentation, I want to focus on so-called primary aspects derived from the literature, being approach, counter movement, upper body usage, arm swing, and knee extension. First, I checked for normal distribution by running Shapiro-Wilk task, checking for smoothness and kurtosis, and then afterwards I ran for sex differences for a cluster of variables, non-over, for the single variables, unovers, for timing variables, mixed ANOVA with repeated measures, to understand the relationship of variables with each other, the Pearson correlation, and last, a multivariate regression analysis was performed for each single primary variable, including sex as a control variable. First result is that males jump higher than females, and this was also shown in the maneuvers, being significant with large effect sizes in basic kinematics, kinetics, and mean muscle activation. And I will soon go into detail what are these single variables. Also the regression models being significant for every single primary variable and showing large effect sizes showed this difference. When you check the multiplying factor of the control variable, you see that these values are in line with the discrepancy of the averages. So this is how the movement looked like. This is the time frame of this investigation from toe-off to take-off, and males showed higher arm velocity and approach velocity. They inclined the upper body more, lowered the center of mass more profoundly, had a larger penultimate step leading to a smaller planned angle, the dominant side, and this leads to greater horizontal force on the dominant side, where we see smaller hip and knee angles engaged, a larger ultimate step in females, and half of the EMG data show differences, 7 of the 10 in the dominant leg. Again, the dominant side is the side of striking arm, so the right one for a right-handed player. To understand the EMG data, it's time for a closer look. This graphic shows you on the x-axis the time, on the y-axis the muscles ordered in what is recommended from the literature as a proximal to distal sequence. So from bottom left to top right, you would have a proximal to distal sequence. When we first look at the non-dominant leg, we see quite such pendants of such sequence in males, but a rather simultaneous activation in females. When we see the dominant leg, for males, except for the vastus medialis, we have a quite pretty proximal to distal sequence activation pattern in males. In females, not at all. Starting with the rectus, the gastro somewhere in the middle, and then last, the gluteus maximus. And 4 of these 5 muscles show timing differences between females and males. The interaction was also significant. Then let's discuss these findings. Higher arm velocity and more inclined upper body tell us that males used the arm's weight and the upper body more to generate momentum, which is facilitating the acceleration for the push-off. Then approach velocity was higher. The penultimate step was larger and this angle smaller. This is a very efficient strategy to convert the higher approach velocity, because mechanically it's more efficient to have a smaller angle here to stop horizontal force, which was shown in the horizontal force in the ground reaction forces. The EMG shows us that this leg was probably used in a different fashion to allow this conversion. And if we lack conversion in the dominant side, what we need to do is to compensate it in the non-dominant leg. How? In the same fashion, by decreasing this angle through a larger ultimate step, which was seen in females. But the problem here is that a larger ultimate step is detrimental for the performance because we push off from a rather split position. So this whole conversion strategy is, in my regard, a very important issue. And to summarize these findings, we can conclude we found sex differences in all of the primary variables, and the strategy, how velocity, horizontal to vertical velocity was converted, differs between females and males. So for the study 2, knowing now sex differences and knowing we cannot make such transfer from males to females, we wonder what is important in females, because we need to know in order to know what to train specifically. So the aim for study 2 was to identify the performance determinants in females. The same data as in the study 1 was used in addition to considering flight phase. This leads to some new calculations in the shoulder and elbow joint during the flight phase. Also the sagittal change of angle was used hereby, and then also the longitudinal change of the pelvis, torso, and the humerus segment were used to derive the rotation angles for pelvis, torso, shoulder. The longitudinal change relative to the global coordinate system in the lab. Then the spike velocity was defined as the velocity, the maximal velocity of the central landmark in the bore, which was calculated based on 2 markers that were attached on the surface of the ball opposing each other. The statistics ran for study 2 were 2 distinct Pearson correlations for jump height and ball velocity, and also 2 distinct forward stepwise linear regression analyses, including only significant correlations and excluding any collinearity among the other variables. So for jump height, 10 out of 42 variables correlated, and they can be clustered into these phenomena of counter movement, being represented by the range of motion, especially in the dominant side. Leg extension, as you can see in the maximal knee and ankle velocity. The approach or conversion, represented in the orientation step length, and arm swing, velocity, as well as backswing angle, but only in the non-dominant side. The regression analysis led to a successful model explaining 82% of the variance by using only two variables, and this model supports the importance of these two variables, orientation step length and the maximum knee angular velocity in the dominant side. No correlations were found for ball velocity. The results closest to significance, meaning below 10% likelihood of type 1 error, are found for the pelvis and elbow joint velocities and the upper arm and forearm length. So why is only the non-dominant arm swing important? One explanation is that, as seen in other studies, the dominant arm initiates preparative action for the strike already before takeoff. This means the dominant side can perhaps not commit fully and contribute in the same way as the non-dominant side to the actual jump. Then the approach was important, shown in the orientation step length, which correlated before with the angle, and this indicates and tells us a lot about the conversion strategy. Engaging smaller angles and greater range of motion can be beneficial for the jump height because it increases the path of acceleration that allows for a higher end velocity of the center of mass at takeoff and therefore for greater jump height. And also the leg extension showed to be important in female. This is not very surprising that this is important for jumping, and for the purpose of technical training is also not so important compared to these ones, because this is a result of technical characteristics plus muscular abilities. So for the training, I want to focus rather on these aspects. Then two explanations I want to give for having no correlations with ball velocity. The first one is that overall coordination between the joints is probably more decisive than the single variables. And the second one is Seminati found different, very subtle, but different styles how to strike the ball. And this leads to two different subsamples, leading to statistical challenges. So we know now quite good about the determinants for the jump height, and we can train that. Usually the jump height is trained through muscular abilities, improving them. But now, as we know differences in technique, and we know the determinants, the technical ones in females, we can implement a technical training. So the goal of this study was to implement the technical training and to assess its effect. I did this with one female team from the highest national team in Austria, and 12 females completed the whole study. They came 3 times into the lab for measurements. These measurements followed the same principles as described before. Between the first and the second measurement, there was a so-called control phase with no intervention, just regular volleyball training. Between the second and the third measurement, there was an intervention phase going on with the identical regular training plus the technical intervention going on. All this took place during the competitive season. This is important to assess the effect of the training. We had a 90% participation rate across all trainings and athletes, no dropouts, and 1 minor injury during the control phase. After 3 days, this athlete was cured and completed already. The intervention itself was 2 training sessions per week, each 15 minutes, and it was integrated within the regular warm-up. And what we did is addressing specifically these determinants we found out earlier, and allowing for variations in these determinants in terms of how to implement the arm swing, the counter movement, the approach, the conversion through the dominant leg. When they came to the lab, their trials were recorded with Policis cameras and anti-force plates, and the data processing followed as described before. again after checking normal distribution. This time there was ANOVA with repeated measures at 3 levels ran for 3 different times, with afterwards manually conducted on Carboni, and an ANOVA with repeated measures at 2 levels for comparison of the development during control phase and the development during intervention phase. And this is how these developments look like. Short explanation. In the middle you see this gray circle. The ash explains the 0% change. Everything that is inside is a negative change. Everything that is outside is a positive change. The further you go outside, the more positive the change was. On each of the axes, you see a variable. The dotted line is the change during control phase in percent. The bold line is the change during the intervention phase. And now on the left side, you see variables that are rather strength related, and they did not change, they were not significant. On the right side, you find the variables that describe the technique, and all of them have been significant. And most importantly, we have an improved jump height of about 12% during the control phase, and a decrease during control phase of about -5%. This decrease in jump height during the control phase is normal, was expected because it was reported before, and the reason is because all this took place during the competitive season. And here we have the stress and the physical load of matches, so it is hard to maintain over the season to maintain the same level of performance in jump height and volleyball. By the way, a very similar design was used here, and this was also the reason why I made the design in this way. Then second, the intervention showed that it is able to affect technique and allows for adaptation at technical levels, and it also was able to improve the performance of the jump height. Then this differential training concept showed to be effective and efficient, and especially when considering the time investment, it was very practical. And when comparing the effect with other studies where intervention of any sort were done, it was superior. My conclusions for this overall PhD project have been that to improve the understanding of a movement and the underlying mechanisms and phenomena, it is very helpful to approach with a holistic data collection method, like involving not only kinematics or only kinetics, but using kinematics, kinetics, and EMG data was really helpful, especially when it comes to revealing the importance of the velocity conversion strategy. The second thing I want to underline is that there is potential in improving technique, even in very high level athletes. And I think this goes especially for sports where we have dynamic situations, and it is an important task for the athletes to adapt to them. And this also goes for high level athletes who have already well developed strength abilities, where we can tune and improve, getting more improvement in the technique maybe. And then third, I want to stress that also in differential training, this study showed that it can be helpful and efficient to specifically address performance determinants. This is not self-explaining because in many differential training studies, the variations have been quite random rather than focusing on specific variables and performance determinants. So I want to thank you all for attending and listening, and want to close with the 3 studies I did for this PhD. Thank you very much.